Hello, everyone. Welcome to our presentation on our senior design project proposal. We will be doing a feasibility study of heat pump water heaters.
Introducing our team name. Our team name would be Team Grid Life. I'm the first member, which is my name is Ben Hero Roman, and my major is electrical and electronic engineering, focusing on the power system side.
Hello, my name is Brandon Aegis, and I am a mechanical engineering major.
Hello, everyone. My name is Christian Sotelo. I am an electrical electronic engineering major with a focus on power design, and I am also the team lead.
Hi, I'm Donald Arnold. I'm focusing on electrical engineering, hoping to focus in power.
Hello, my name is Megan Rodriguez. I'm also electrical and electronics engineering with the focus in power design.
Hello, viewers. My name is Randall Grill. Likewise, I'm an electrical engineering major with a focus in power. And with that being said, this is everyone who represents our well-rounded squad. Transitioning from our member introductions to our potential clientele, we have teamed up with the Sustainability Department here at California State University of Sacramento to produce and present a feasibility study of heat pump water heaters and their viability as an energy-saving solution on campus. Conversing on over, the summary of our project as a whole will be defined through studying the usage and implication of heat pump water heaters versus traditional electric resistant water heaters and gas heaters in domestic and industrial settings. We will not only eliminate natural gas usage, but also minimize the electrical demand of a typical water heater. Furthermore, our installation will result in cooler external temperatures, which will inadvertently help HVAC demand also. Our study will be done through the analysis of electrical loads throughout different seasons on an individual building. Singling out a specific area will help us determine precise loads and feasibility of the water heater design throughout the year so we can reach maximum efficiency.
With that being said, due to increasing regulation in the energy sector, research on higher efficiency technology has become imminent. Implementation of heat pump water heaters will be crucial to phasing out fossil fuel and inefficient electrical heating systems. Natural gas prices are currently increasing and will continue to increase as natural gas becomes more scarce, while other natural energies such as heat created from the sun will always be abundant.
For our purposes, we'll be focusing the study on Riverview Hall, located on the Sacramento State campus. As shown in the graphs below, we believe this is a good starting point for the research of water heaters both in natural gas and electricity usage. Taken from the Sustainability Department's dashboard is a screenshot of Riverview Hall's gas usage graph throughout the year 2021 and 2022. As you can see by the graph, there is a sliver of usage from July to November, with a sharp rise in usage between December and January. And from January to February, you can see a slight plateau. And from March to June, you can see low usage. Next is another screenshot from the Sustainability Department's dashboard for Riverview Hall's electricity usage throughout the 2021-2022 year. As you can see, we can see a steady increase of usage from July to December, and from December to March, a plateau of usage, and from March to June, a steady decline in usage.
Thank you, Christian. As stated on our problem statement, minimizing natural gas usage and making it more cost efficient is a priority. In order to find the right procedure, we will then analyze and validate through the methods of thermal and fluid analysis. We as Grid Life want to fully maximize the thermal efficiency from a heater and to also reduce power usage and costs. Thus, getting into more of the power system analysis side, we must understand how the power usage work by comparing our calculations to the gas and electricity usage data throughout the recent years and seasonal periods, meaning these heaters could save electricity.
The strategy that we're going to go about to solve these issues is that we're going to collect data on the current electrical and gas usage that the current system is now using. Afterwards, we're also going to be inspecting the Riverview Hall itself here. and how the current system is affecting the students' welfare, as well as the environmental impacts that the current system is having and what the new system will do to the students and environment. After that, we'll be doing intensive energy calculations, as well as calculating the installation and maintenance costs based upon the old system, as well as what we're planning to install into the building.
We will then proceed to calculate the energy usage throughout the year using the new water heater model. Then we will calculate total costs with all factors included. These factors include things such as maintenance costs, installation costs, and material costs. We will then compare the theoretical energy usage of the heat pump water heater versus the current energy usage of gas water heaters and electrical resistance heaters. And ultimately, we wish to improve the current heat pump water heater design to increase thermal efficiency and power usage. For example, a current complaint of the heat pump water heater is that it's very noisy. There's high-speed fans in it that produce a lot of noise. That is something that we look to improve on. Another thing we look to improve on is instead of using a 240 volt heater, we want to use a 120 volt heater. And this is mostly due to installation costs, which can be expensive for certain buildings that don't have a 240 volt plug-in. So this is another thing that we are looking to improve upon.
Thank you, Brandon and Donald, for our strategy, and thank you to everyone that watched and listened to our presentation. Hope you enjoyed our project proposal. Team Grid Life out.